A second chance, hope for the unwillingly departed. The human spirit yearns for eternity, for a defiance of the seemingly inevitable curtain call of death. This yearning becomes agonizing when one's final wishes are left unfulfilled, particularly in the case of cremation. The irreversible nature of this act can leave loved ones with a profound sense of loss and regret, forever wondering if their departed would have wished for a different fate. What if science could offer a second chance? A way to honor those final wishes, even after the flames have subsided. Imagine a world where cremation is no longer an insurmountable barrier, where the essence of an individual could be resurrected, granted a new lease on life. This may sound like pure science fiction, but recent advancements in bioengineering and artificial intelligence are bringing us closer to this once unthinkable possibility. This essay delves into the fascinating realm of resurrection technology, specifically focusing on a revolutionary device designed to reverse the process of cremation. We'll explore the scientific principles behind this groundbreaking invention, examining its potential to reunite us with loved ones we thought were lost forever and redefine our very understanding of life and death. The spark of life, mimicking the essence with silicon and light. At the heart of this resurrection technology lies a sophisticated microprocessor, a marvel of miniaturization and complexity. This tiny chip serves as a digital vessel capable of storing and replicating the unique life essence of an individual. But how is such a thing even possible? The key lies in understanding the nature of consciousness. While the exact mechanisms remain a mystery, emerging research suggests that consciousness arises from complex electromagnetic patterns and quantum interactions within the brain. This bioelectric symphony, unique to each individual, is what defines our thoughts, memories, and personality. The microprocessor in our resurrection device is designed to capture and replicate this intricate symphony. It achieves this through a process called biophotonic mapping, where a specialized laser scans and records the residual bioelectric patterns within the cremated remains. This information is then translated into a digital format and stored within the microprocessor's quantum memory core. Think of it as a high-tech fingerprint, a digital echo of the departed's consciousness. This digital essence forms the blueprint for the resurrection process, guiding the recreation of the physical body and the reawakening of the mind. Recreating the vessel from ashes to flesh and bone. With the digital essence safely secured within the microprocessor, the next stage involves rebuilding the physical body. This is where the true magic of bioengineering comes into play. The device utilizes a combination of advanced nanotechnology, stem cell manipulation, and a specially formulated bioscaffolding to reconstruct the deceased's body with astonishing accuracy. The process begins by extracting bone marrow stem cells from the cremains. These powerful cells, capable of transforming into various tissues, are then placed within the bioscaffolding, a three-dimensional printed structure that mimics the exact shape and structure of the deceased's body. Within this scaffold, a network of artificially grown nerves and muscles is meticulously woven, connecting to the microprocessor at key junctures. These artificial nerves, composed of biocompatible polymers and infused with growth factors, act as conduits for the microprocessor's signals, mimicking the intricate neural pathways of the human body. Meanwhile, the artificial muscles made from electroactive polymers that contract and expand in response to electrical stimuli provide the physical framework for movement and interaction with the environment. The unfolding of rebirth, a step-by-step guide to resurrection. The resurrection process itself is a carefully orchestrated symphony of science and technology, a delicate dance between the digital and the biological. It begins with the activation of the microprocessor, which sends a surge of bioelectric patterns through the network of artificial nerves. These patterns, mimicking the unique neural activity of the deceased, stimulate the stem cells within the bioscaffolding to differentiate and grow. Over time, bone, muscle, cartilage, and skin begin to form, gradually filling the scaffold and recreating the deceased's body with remarkable fidelity. Simultaneously, the microprocessor begins to interact with the newly formed neural pathways, feeding in sensory information and prompting the nascent consciousness to awaken. This process is akin to teaching a newborn baby to see, hear, and interact with the world around them. The final stage involves a gradual weaning off of life support systems as the resurrected individual regains their strength and coordination. Throughout this process, a team of psychologists and medical professionals provide constant monitoring and support, ensuring a smooth transition back into the world of the living.